Point two, got a little more fraction work to do here today, really just to remind you of some things. All right, here in example number one, it says express each rational number. It's a rational number because it's written as a fraction. Of course, we know that rational numbers can be written as fractions. That means they can be written as an integer over an integer. Okay, irrational numbers cannot, like pi. Pi does not have a fraction form. It does not equal anything, any integer divided by another integer. Okay, so it is irrational. Okay, but rational numbers can be written as fractions, and I've got one right here, 4/7, and they say express the rational number as a terminating or a repeating decimal. Now, guys, we have electricity now. We have computers now. We have calculators now. You know that you always divide the top number by the bottom number. Using your calculator, okay, you want to type in 4. The top number is always typed in first. Press the divided by sign, 7, and then hit enter, okay? Now, I know that you know this, but some of you don't, okay? So, that's why I'm showing you again. I just want to remind you. So 4 divided by 7, enter. And we're going to get this, okay? This is equal to, well, here, let me move these down, okay? And just say that this is equal to 0.57142857 Now that's interesting. And then my calculator stops, okay? Now, what do you think is repeating? It looks like every one of those digits is repeating, okay? And then it pops back to 5, all right? And so we can get rid of those 3 digits because we're already saying these are the things that repeat. 5, 7, 1, 4, 2, 8, 5, 7, 1, 4, 2, 8, 5, 7, 1. You get the idea, okay? So, there we go. It's a repeating decimal. And remember, guys, with rational numbers, any decimal that repeats, like this one, or ends, can be written as a fraction. It's decimals that don't repeat and do not end that are irrational, like 3.1, 4, 1, 5, 9, 2, 6, 5, 3, 5, 8, 9, 7, 9, 3, 2, 3, 8, 4, 6, 2, 6, 4, 3, 3, 8, 3, 2, 7, 9, 5, 0, 2, 8. You get the idea, okay? That's pi. None of these digits repeat. We don't know what the next digit's going to be, okay, until we figure it out. All right, so pi is irrational because it never repeats and it never ends. It cannot be written as a fraction, okay? Now, just a little piece of information that you need to know right now is that, because we're going to be talking about this later when we're dealing with radicals or square roots, okay? If I take the square root of a whole number, like 8, and I do not get a whole number when I type it into my calculator, all right, the square root of 8 is equal to 2, or it's approximately 2.828427125 ... Okay, if I take the square root of a whole number and I don't get a whole number, this thing is irrational. That means there is no fraction that equals it. Okay? If I take the square root of a whole number and I get a whole number, now that number is rational. Okay? But this is an important concept to keep in mind, that there is no fraction that represents the square root of a whole number that doesn't come out to a whole number. Okay? Now, let's look at some more examples, some things that we're going to be asked to do. Express each rational number as a fraction in simplest form. Here's a repeating decimal. We need to know how to write it as a fraction. Okay? Here are the steps. 1. Multiply by a power of 10. Well, let's see. Let's just do this. This is an easier way for me to explain it to you. this number has 2 digits repeating. So I'm going to multiply it by 100, a 1 with 2 zeros. Okay? Now, if I say that this is n equals 0.07 repeating, then 100n is equal to 7.070707, right? Okay? Now, it's that, right? Because I multiplied it by 100. I moved the decimal point 2 places to the right. Now, what I want to do next is I want to subtract n from this. All right, so 0.07 repeating. You see why I multiplied it by 2? Because now I have the same things behind the decimal point. So if I subtract them, yes, this just goes away, and I'm left with 99n is equal to 7. Divide both sides by 99, and n is equal to 7 over 99. Oh, so you mean that this up here is 7 over 99? Yes, that's what they said they want us to do. Write it as a fraction in simplest form. And I can't reduce that. 7 doesn't go into that. Okay? Does that make sense? Here, let's try another one, just quickly. I don't know. I'm just going to make one up. We did that one already. Okay? Let's try, how about 0.14? 143 repeating. Okay? Now, since I'm just going to first say, let this equal n. Okay? And this one I'm going to multiply by 1,000 because I've got 3 numbers that are repeating. So I'm going to multiply by 1 with 3 zeros. So 1,000 n is equal to 143.143 repeating, right? Because I moved it over 1, 2, 3. But what's behind there? Well, 143, 143. Okay, it keeps going. Okay? So 1,000 n equals that, and n is equal to 0.143 repeating. Oh, so now you see why we multiplied by 1,000. Okay? When I subtract, this just goes away. Okay? And I'm going to be left with 999n is equal to 143. Divide both sides by 999, and I'm going to get n is equal to 143 over 999. There we go. That's what that is. Let's do one that's not quite as straightforward. How about this? How about, let's do, about 0.16 repeating. Okay. Well, first off, let that equal n. Okay. How many digits are repeating? Well, just 1 digit's repeating, just the 6, right? The 1's not repeating. So I'm going to multiply it by a 1 with 1 0. So 10n is now equal to 1.6 repeating. Okay. And remember, n is equal to 0.16 repeating. Okay. Well, think about this. What's behind this 6 up here? Well, another 6. Okay, good. So now when I subtract, these just go away. All right? And I'm left with 9n is equal to 1.5. Okay? That's good. Now I'm going to divide by 9, and I've got n is equal to 1.5 over 9. Ooh, I don't like a decimal in a fraction. Okay, well, let's do this. Just move it 1 decimal place. Right? So now I've got n is equal to 15 over 90. Okay, good. Now I just need to reduce that. Well, wait a minute. 15 goes into 90. Okay, well, maybe you didn't see that. Maybe you just saw that 3 goes into both of them. Say 3 goes into 15 5 times, and 3 goes into 93 30 times. And then you see, oh, look, 5 goes into 30. So 5 goes into 5 once, 5 goes into 30 6 times. So this decimal that was up here is equal to 1/6. Done. All right? I think you've got a pretty good handle on that. Let's look at this next one. Find the number halfway between the given numbers. Well, the first thing I'm going to do is, if I can write them both as decimals, I'm going to. I don't know if 5/8 is repeating. Let me just try that. 5 divided by 8. Okay. Uh-oh. 5 divided by 8. Oh, look, it's not repeating. It's 0.625 and 0.634. We'll find out the difference between them. Just subtract 0.634 minus 0.625, right? And that's what, 0.09? Yeah, there we go. All right, now I need to half that, okay? So that's going to be 0.009 divided by 2. So that's now, half of that is 0.0045, okay? So that's half of the distance between these two. So I'm just going to either add it to this one or subtract it from this one. And just add it to 0.625. I'll just put a 0 on the end. 5926.0. Okay, so 0.6295. This is the number halfway between here and here. Okay, since they didn't give them both to us in fractions, they gave one in a fraction, one in as a decimal, I can leave my answer as a decimal if I want to. Okay, that's fine. If they had given it to us in fractions, then the answer should be in fractions. If they had given it to us in decimals, then the answer should be in decimals. But they gave us both, so I get to pick. Okay? Remember, we've done this before. We did this yesterday. All right, good. Let's look at number 4. Express both numbers as fractions, then find their products. Well, it's nice to know this one's already a fraction, and it's simplified. But this one over here, just read it. 875 thousandths. Okay, 875 thousandths. Okay, now I need to reduce it. I can tell easily that 5 goes into both of them. 875 divided by 5. Okay, that's 175 over 200. Oh, it looks like 25 goes into both of them. So 175 divided by 25 is 7. And 200 divided by 25 is 8. Okay, now that's reduced. Okay, so they said that now they want the product of these two things. Easy. Multiply them. 7's cancel, and I'm left with 5 over 8. Beautiful. Done. Done. 4 problems, 4 explanations, and I took a long time explaining how to convert repeating decimals back to fractions. I hope you got that again. I hope you got that. Okay, remember, you always let the decimal equal n, and then you multiply it. You want to move the decimal, the same number of digits that are repeating. So if you have 1 digit repeating, you multiply by 10. If you have 3 digits repeating, you multiply by 1,000. And then you just set up an equation and subtract. Okay? But anyway, I've said that enough. You can go back and look at it if you want. You guys know how to look at the internet and find some other videos that talk about that as well. So you guys are good to go.